now, meaning if there are people on the call in the rooms who were
There's a
not.
message from Amit. Not sure if Amit is able to hear us now.
Yeah, now I'm
is
able
it?
to hear.
Okay.
Now I'm able.
Okay. Yeah. So other than examiners, if participants in the call in the room have any questions, Nidhi can take it now. Thanks to some of them for joining. I see some who are not part of IIIT now, some who were part of IIIT Delhi long time back. All of them joining the call. Very nice to see some of you. I can recognize only some of your names on the teams. Thanks. If there are no questions from the audience, we can go with the examiners. So now, for the benefit of students, everybody in the call can stay. And particularly if you're research students, please continue staying. So you will know what kind of questions are asked to the PhD candidate. Let's go in terms of distance. Mavish, do you want to go? You're the farthest for all of us.
Yeah. All right. So I have two kinds of questions, some specific, some very general about your thesis and the overall field that you are working on. So thank you for the presentation. That was really very nice technical contributions that you did, and you published in very good venues, which is really nice for a PhD student. And yes, it was really, it looks like really active research that you did during the PhD. So everything is, I liked it a lot. And of course, it's my area of research, so I was really enjoying the talk. I will start with the specific ones, and then I will go towards more generic ones. So please let me know if there is a time limit to that. So you have to indicate, somebody has to indicate me this. So on slide 23, you were talking somewhere about negative pairs that you generated randomly. I mean, if you remember, you don't have to go to the slide, but
yes,
I just gave you the indication. So do you think you can sort of use like some external knowledge to improve this kind of negative pairs if you can, for example, then it's not random anymore, it's a little bit more controlled. Do you think this could help you? Do you think it is useful to do that? And do you think it will help you improve your algorithm somehow?
okay. Thank you. Thank you, Professor Mahesh, for your question. So yes, so we, in our case, we took random samples of negative pairs. But definitely there are other ways where some of the methods in the existing literature, they focused on taking hard negatives. So by hard negatives means there are some overlap of, let's say, words between these two entities, but they are negative entities. So that is that could be possibly one of the interesting direction where we can also incorporate domain specific knowledge to find out that these which two entities are used together, but they are not actually the same entity.
Okay. Okay, right. And then I have another question. You were referring to Google KG within this work. Is it still active? What do you mean by Google Knowledge Graph?
So Google Knowledge Graph that we used in this work, it was a SERP API, which is a search API released by Google. And this API is dynamic. So in terms of data, I would say the data that we can collect today versus the data which is collected, let's say, a few months back, that particular information that may vary. So that SERP API directly hits the Google search engine, and it brings the information from the Google Knowledge Panel, which is present on the right-hand side, and all the attributes. So for an example, for any entity, if there is a text or a description. So for an example, the entity like MIT India. So MIT belongs to Madras Institute of Technology, India, not the MIT in actual. So when we does this kind of location specific search using this API, the side information collection, this side information get returns by the search API of the Google.
Okay, which so if you think about other general purpose knowledge graphs like Wikidata and things like this, do you think they will be useful in that sense, or is there a specific reason why you went for Google Knowledge Graph?
Yes, so actually this is a good question. So in terms of side information, we explored a lot of resources. So existing literature, they used paraphrase databases, which were more limited to generic knowledge. And then Wikidata, we also explored Wikidata. And also in this work, we used not only the Google Knowledge Graph, we used Google Info Boxes as well. The thing where we wanted to try the Google Knowledge Graph is because most of these variations, these are noisy and ambiguous variations, which sometimes do not have a specific context which is present. And in the cases it has some context present, there may or may not be Wikipedia info boxes or wiki information which is present for them. So in order to supplement that context, we query Google Knowledge Graph and Wikipedia info boxes, both type of information, so that we are having some context regarding to the entity that can help the model to understand better with respect to which entities are more closer in the space. Yes, so the architecture is not limited to particular type of side information. It is open to incorporate any side information that can be used, that can be present in the space.
All right. Okay. Then I have another question. You were using, if you go like 1-2 slides further, it's for me to see actually, like 25th, I think.
Okay, it's back or further?
Further, like 25th slide or
Okay.
26th, I don't remember which one. Yeah, 25th.
Yes.
Previous one. Okay, both are fine. So my one question is, when you are here generating embeddings, you are using BERT. This is what I saw on the next one also, and you said that. Did you try to do something with Word2Vec, for example, because BERT is known for keeping the contextual information. Do you need this kind of contextual information to be captured? So just like an overall idea of, do you think how would it differ? Because possibly, because I have seen from my experience, sometimes when you do not need contextual information, Word2Vec gives you better results. Did you try it, or what do you think about that?
Yes, definitely. So we did not try Word2Vec on our data, but there is a literature which was the domain specific literature from the recruitment data itself. They tried out with one advanced version of Word2Vec, which is FastText, taking into account the character embeddings as well. So here, if you see this CAD by LSTM plus A, Word by LSTM plus A. So all these three approaches in the row, they are using FastText embeddings as an initialization. So the reason for them for using the FastText initialization was that most of the recruitment content, they have new and emerging entities. When we use Word2Vec, if a new entity comes in, the model will not be able to give any vector, or it will be out of vocabulary problem for the emerging entities. So that's why they did the experiment with the FastText. And so we compared with these models which were initializing with the fastest.
Yeah,
That,
but
yeah.
But you know, in such cases, when you have this out of vocabulary kind of errors, you can actually train it on your own data, because this is
Yes.
trainable. No, Word2Vec is trainable. You do not have like huge amount of data like BERT or even large language models.
Yes,
Yeah.
yes. So we can,
But yeah,
yes,
yeah.
yeah, I agree. We can train it on our data. Then one more problem is that the data is itself evolving. Then we have to train it again and again. So in order to just get rid of that particular problem, where BERT kind of model use byte pair encoding to find out some representation of a even evolving entity, we thought to go ahead with the BERT.
Okay. Yeah, great. Just for your maybe information that there is another version of Word2Vec which is taking care of evolving information, but this is just something ongoing right now. Okay, I will move on to my next question. So in the second work that you have, this was, it was slide 37, if I'm remembering correctly. Okay, no, yeah, so here, in this case, how did you take care of different node types? Because you said that you had two different like skills and jobs. These are two different types of nodes. Did you, while learning, while doing your whole experimentation and learning your network, did you try to differentiate them, and how did you do that? And the second part of my question is, what if you only use the string information, like you have job and the skills, and you just use simply like NLP, that's it, you do not convert it to graph? What happens then?
Okay, that is really an interesting question, Professor Mahesh. So I will answer the first question first. So if I repeat it correctly, you are asking that how did I take care of heterogeneous kind of nodes while modeling them into the graph neural network,
Yes.
right? So, so for both of these two nodes, we started with their raw text. So job description has the raw text and skill also has the raw text. We first use NLP models to actually embed them into some low dimensional representation. So once we have those representations, we have two representations of nodes, one for the job node and one for the skill node. So those two representations, they have same dimension. And then finally, when we connect them in the graph, at the time of saying that this particular job, this particular skill is relevant to this particular job, the graph is able to iterate over these representations and able to learn node neighborhood. So we are using graph neural networks here, which is graph isomorphism networks, which takes into account the neighborhood information, at the same time the node information as well. So if I am on this orange node, so I will be able to learn 3-hop neighborhood in the, yes. Yes, so at the first layer, I have the representation of this node and the representation of the orange node, which is the skill and the job. So in the first iteration, it will take care of all the information of this node, which is in purple, plus the information of the node in the orange. So so as we progress after that, the second hop neighbors and third hop neighbors. So in terms of embeddings, it do not make any difference in terms of representations, whether we have different type of nodes or not.
Yeah, that's what I actually wanted to know. So just for maybe for future work, but I mean, this is already a good work that you did, a good thing that you did. So there are some embedding algorithms which are doing learning like two-dimensional, like you have this type information, then you have this factual information. You could also try to use this as a separation between them, possibly. I don't know. I mean, I'm just trying to think from the generic point of view. That could possibly be one of the extensions.
Thank
right.
you. Thank you for your suggestion. Yes.
Another question